Determine the bounded area highlighted in red. This time let's use rows here. So we're going to have rows here with a height of dx and a width of w. Okay, so our small area here, our dA, is equal to width times dx. But we don't want a dA, we want the whole thing. We want to have a. So we're going to integrate this thing, and I've already made a mistake. This is not dx, I'm in y here. This is dy. X is this way. So this is dy. This is dy. Okay, perfect. So the integral of 1 dA is equal to a. And this integral is going to be, well, I need to figure out a whole bunch of stuff here. I need to put all this stuff in terms of y. So I need to put w in terms of y, and I need to find my bounds of integration. So the bounds of integration in terms of y are going to go from 0 all the way to this height right here. That's where I want to integrate from. So from 0 to, well, this polynomial here is in plotting form, so we know that this vertex is at value of 1, 1. Okay, so there's the x value of the vertex, and there's the y value of the vertex. So we know it's 1. So it's going to be 0 to 1. Next thing we need to do is we need to put w in terms of y. Okay, how are we going to get that thing? Well, we can solve this guy for x. Let's do that first. Okay, let's solve this equation for x. So first thing we're going to do is we are going to, let's bring this guy over and bring that guy back over. So it's going to be, x minus 1 squared is equal to 1 minus y, and then we can square root it and then add the 1. So x is equal to square root, so it's going to be plus or minus square root of 1 minus y, and then we need to add this 1, so plus 1. Okay, let's put it a little neater here. So x is equal to 1 plus or minus square root of 1 minus y. Okay, so the plus or minus, it really shows that there's two solutions. So given a y value, there's two solutions for x. So let's say given a y value of 0.5, okay, there's two solutions that x can be. X can be either here or it can be here. Okay, and that's what you have. So you have 1, it's 1, the vertex here, so it's symmetrical about this axis here. And that's why we start at 1. So it's going to be 1 plus this value or 1 minus this value. Okay, so that's why you have two solutions. So for me to get the distance, remember this distance here, x, is always measured from x equals 0, right? This x equals 2 is 1, 2. It's measured from this axis. So for me to get the difference here, I'm going to take this value minus this value, right? Because I want to have this distance, which is from the y-axis, minus this little guy, which will give me the difference. Okay, so that might have to be worked out in your head, but I think what we can write down is w is equal to, I want the plus side, so it's going to be 1 plus the square root of 1 minus y, minus 1 minus the square root of 1 minus y. Okay, so because this guy here, 1 minus, gives me this distance, and this guy, 1 plus, gives me this distance. So if I take this distance minus this distance, I'll get my w. That's exactly what I want. Let's simplify this guy before I put it into the integral. So it's going to be 1 minus 1, which is 0, and then this will be 1, this thing minus that negative, so it's going to be 2 square root of 1 minus y. Okay, let's take that thing, shove it into here, and let's put it a little more integral-friendly format. So it'll be 1 minus y to the power of 1 half dy. Okay? We can take that integral straight up. We can do a substitution though. Let's take a substitution. So we're going to let u equal to 1 minus y. So du by dy is going to be equal to negative 1. So therefore dy is equal to negative du. Okay, so let's do the substitution. So this will be the integral from 2 u to the 1 half. Dy is equal to negative, so I put a negative in here, and a du. Okay, fantastic. Limits of integration will change because now we are in a basis of u, so we have to change everything. So we put the 0 into here, so 1 minus 0 will be 1, and then 1 minus 1 is equal to 0. Okay, so it's kind of weird, it kind of just flips, but that is just into our new basis. Let's do this integration. So we're going to get, where is this? So it's going to be 3 over 2, so it's going to be minus 4 over 3 u to the 3 over 2, 1 to 0. Right, so if I multiply this guy down, the 3's cancel, 2, yeah, so I'm left with that. Yeah. Okay, so we can, again, we can do this. I'm actually going to do it this time. I will put these values in here and I'll show you, but I will take a little side step and I will do it the other way by putting it back into x. But let's just do it this way real quick because it's so simple. Minus 4 over 3 times 0 to the power of 3 over 2 minus negative 4 over 3, 1 to the power of 3 over 2. So this is 0, and then negative, negative, and this is going to be 1. So it's going to be equal to, the answer is going to be equal to 4 over 3. Okay, but putting it back in terms of x, we can show that it's going to be negative, what is it, negative 4 over 3 u, which was equal to 1 minus y, 3 over 2. And now we're back in terms of y, so we can put it back to a regular form of integration, or a regular bounds of integration. And now we can plug all this back in here. So minus 4 over 3, 1 minus y, 0, the first one, over 2, minus negative 4 over 3, 1 minus the second bound is this one right here, 3 over 2. And now we got it. So this guy is going to be a value, this guy is going to be 0. And now we're going to have negative 1 minus y, 0. I don't know why I get a negative here. So is there a negative to begin with? du. I'm sorry, my bounds are wrong. You can see that. I used a different bound. The 0 and 1 caught me. So this one actually should be, if going back to my limit, for my y, it's 1 to 0, not 0 to 1. So it's 1 to 0. So this one should have been a 1, and this one should have been a 0. That means that this one should have been a 1, and this one should have been a 0, meaning this one goes to 0, and this one stays, and you get the negative negative, which leaves you with a positive 4 over 3. Whew! Okay, so the area is equal to 4 over 3, which is equal to 1 over 3, 1.3 repeating.